Hello everyone. I hope you are having a great day. Let's talk about user-defined types. Let's say our team is creating an animation for fun of a couple of bouncing circles. Someone is working on creating graphics and you are responsible for keeping the information about circle's location at all times. To store the circle location, we would need its center x and y and the radius. We can create variables like center x, center y, and radius to represent one circle. But now, if we want to manage 10 circles, we would need 30 variables, and the code looks messy. We can organize it better by creating 3 vectors for x, y, and radius. However, it still doesn't translate well to how we visualize the animation. We see a couple of circles bouncing around, not x, y, and radius. C++ allows us to create user-defined types as a collection of same or different types of data. Let's turn a circle to a user-defined type. We can create a struct user-defined type using keyword struct followed by name, the circle in this case, and a block terminated by a semicolon. A point center and a radius represent a circle. Here, the point is also a user-defined type. Let's define a point as x and y. We can have same kind of data in a struct, or we can mix different types of data. We can even have another struct inside one struct. Now, we can define a vector of circles, which is more like how we visualize them. The variables grouped together in a struct are member variables, and we can access them using the dot operator. Let's work with one circle example for simplicity. We can update it later to a vector once the struct concepts are clear. We can initialize a struct using curly braces and listing each variable separated by a comma. We initialize first the outer struct, which has one point and the radius, and then inner struct, which has x and y location. We can also input the values from the user. Let's also define some functions for circle like diameter, parameter, and area. Ideally, we should have another function move to move the circle to a new location. But to keep the example simple, we leave it out. We can use these functions passing in the circle as a parameter. However, we define these functions separately from the circle type, so it's not as apparent and users might end up using their variant. C++ allows us to relate functions to type by defining functions inside a struct. All the functions inside the struct have access to other members, so we don't need to pass in circle as an argument, and can directly use the variables. Since these functions are members, we use the dot operator to access them, just like the member variables. The code looks more organized now. However, there are still 2 problems. Even though we associated functions with the type, nothing stops users to again directly using their variants. Another issue is the user can pass in a negative radius, which is wrong for our implementation. How can we prevent the user from abusing our type? We can use another user-defined type called class. The usage is similar to structure, except we use the word class. Class hides all members from the user by default, or in C++ terms, everything is private and users can't access them from outside class scope. Now, if we compile the code, we see many errors, since we can't access anything from the class. We have restricted users from accessing the member variables, but also the functions. C++ allows us to make a section of a class public by using the tag public and colon. Users can access anything public from outside class. Okay, we can access the functions now. But since now we can't access the member variables, we have no way to initialize the class. C++ gives us a way to construct the member variables using a particular function called constructor. The constructor function has the same name as the class and can take arguments to initialize the member variables. Here, we initialize the variables inside the function body. But C++ has another concept called Initializer List. It is a bit of a weird syntax and only applicable to constructors. Before opening function block, you can type a colon followed by the member variable name and the initialization value in braces. Likewise, we can initialize all other variables followed by comma. Initializer list initializes member variables with the correct value in the first place. If we initialize them inside the function block, C++ initializes them first with the default value and then the value is assigned. Now, users can't use their variant of the function. Users can still pass in an invalid radius. We should fix that. Now, since the radius is not a trivial initialization, we cannot initialize it in the initializer list and need to move it into the function block. Let's add a check. If user passes in a radius less than or equal to 0, we can print a message saying the minimum radius is 0.1 and initialize the radius to 0.1 instead. We can keep the point as struct since all the values of x and y are valid for point and we don't need to make them private. The convention is to use struct when the member variables are public and it has no functions. This convention follows from how we used the struct in C programming language. So the structs are backward compatible if ported in C language. However, technically the only difference between struct and class in C++ is struct have members as public by default and class has them private. That's the only difference. So in this example, if we make the scope explicit by using private and public tags, we can use struct and class interchangeably, and the compiler wouldn't mind. However, as I said, the convention uses struct with public member variables where all values are valid and have no functions. Most other C++ programmers reviewing your code would expect similar struct and class usage. Let's complete our code using a vector of 10 circles. We initialize each circle inside brace, separated by comma. Let's test our code. We see the diameter, parameter, and area of all 10 circles. For more programming videos, hit the subscribe button, leave a comment if you want me to cover any specific topic, and share with your friends. Thanks for watching.